Empirical formula. Late 1700s, chemistry was really getting going, and a lot of chemists were experimenting with elements to see how they formed compounds. And so they would do things like they would take a measured mass of an element and react it with oxygen, and then they'd measure the mass of the product, the oxide compound, and then from that they could figure out what the formula of the compound is. This is called an empirical formula. It gives us the simplest whole number ratio of each element in a compound. And the word empirical means based on observation or experience. This isn't something based in theory, calculated from the periodic table or anything like that. This is an experimental result. So let's see how they did that. So here are the steps. Your book doesn't actually list out steps, so I wrote some down for you. Determining an empirical formula. The first thing is we need to find the mass of each element in the compound. Sometimes it's given to you, sometimes you have to figure it out. Then we're going to calculate the moles of each element, because the formula relates numbers of particles, and a mole is a counting unit. So we need to find moles, and then we're going to find the mole ratio. And we're going to do this by taking the number of moles and divide by the smallest. And that way we'll get some reasonable numbers. And then we're going to convert those ratios into whole numbers. So those are the basic steps. Here is an example we're going to do. 1.15 gram sample of cobalt was heated with oxygen to produce 2.025 grams of cobalt sulfide, the compound. Determine the empirical formula. So the first thing is to find the mass of each element. Well, the mass of cobalt is given to us. They don't give us the mass of sulfur. But why does the product weigh more than what we started with? It reacted with sulfur. So this is a situation where we're reacting with sulfur, not with oxygen. Oh, yeah. I changed the example. My very, very bad there. It was heated with sulfur. I didn't even catch that when I read it to you. Heated with sulfur to get cobalt sulfide. The difference in mass is the mass of the sulfur. It got heavier because it reacted with the sulfur. So if I take this number and subtract that one, I'll get the mass of the sulfur. Once we have masses, finding the moles is just a matter of using the molar masses of the elements from the periodic table. We need to remember, though, that these elements are in a compound here, and so we don't need to consider the diatomic elements. And then we take those ratios, those moles, and make ratios and convert them to whole numbers. So let's see how this would work. Let's fix my mistake here real quick. Reacted with sulfur. So we need masses. We've got 1.115 grams of cobalt. And for the sulfur, we've got 2.025 grams minus the 1.115 grams. 2.025 minus 1.1115. I've got too many ones. Yes, I do. Thank you. Okay. Let's try that again. 2.025 minus 1.115. I just got carried away with my ones. My calculator says 0.91. But do you see how each of these numbers has 3 decimal places? Subtracting, I should have 3 decimal places. I had a 5 minus a 5 in that last place, and that gave a 0, which my calculator ignores. I need to put that back in. So there's our mass of sulfur. 0.910 grams of sulfur. Out of time. What to do? Well, we'll have to finish this in activity sessions. So Yeah, I'll see you next week.